since the day it was put in.
I don't want to model any bad habits.
So when we decided to do a presentation on problem solving, one of the things that I know as a math teacher, many of us struggle with, is when we were going through school, our teachers, I just think of my teachers, they just stood up there and they just drive, formula, 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 this is how you do it, proof, here you go do your work. So basically, you know, I didn't really know what it was for, I just kind of just did it. And, you know, I guess eventually, as I got older, it kind of connected. So we've kind of shifted a little bit ourselves. And one of the reasons is because globally the United States is no longer in the top 20 with math and science. So we are falling. And so we have tried to, as a country, we are trying to come up with a solution so that our future generations will be much more successful. So as we continue to look through that, they've been researching the best way to teach math. And, okay. It's going to go all the way through my presentation, isn't it? There. Good? Good. Okay, so we're no more going to just teach students the steps. You don't get to learn just subtract 3 from both sides and now you have an X. And what is X? We don't care. We're not teaching it that way anymore. That's right. We're going to teach them to understand and use analytical skills. So when we start teaching them how to solve for X, instead of saying just subtract 3 from both sides, we're going to say, well, let's talk about what X represents and what's being done to X. So even if I don't have a word problem yet, I'm still talking about what X is versus just, let's subtract 3 from both sides. When I see that plus, I'm going to do minus. That's kind of what I think of as rote. Instead, let's think about, we're talking about a number here. This X represents some number and what's being done to it, and now we're going to undo it. And I think that is one of my key phrases that I teach for my Algebra 1 students and I teach 8th grade, is my youngest class. I go through that all the time. What is being done to the X? What is X? You know, and that is something that I always come back to in any kind of lesson. So we're also going to talk about just in the United States, we also need to break down a problem and learn how to think. That is probably the key point. I even had a student today say, why do we need math? And I just looked at him and I said, because we need to learn how to think. That's why. So, next slide. So, here at Noble, what we are doing, in conjunction with keeping it all connected, because our students do, sometimes I just can't throw out a problem and they know what to do. So I've kind of got to help them make those connections. So we are emphasizing problem solving in conjunction with the mathematical concepts to help students to learn to think. And I'll give you an example of what that means. So flip. If I gave them this word problem, and it says, if I need to rent a car, and the rental company is going to charge a $20 flat fee, plus $15 a day, how much would it cost me to rent a car for 7 days? Now this would be a problem that I might put at the beginning of a lesson, and we would be talking about graphing lines. So it's okay if y'all don't remember that's where that came from, but when you teach it, you kind of know where it fits. So, you know, I look here, most of us can say, well, I'm going to walk in because we have to do this when we rent a car. I mean, we're going to be paying our $20, and then we got to figure out how much more they're going to charge us. So we just didn't do it. We do it innately without realizing that this was a skill we learned in Algebra 1. So if we look at this, I'd say most of us know the answer is $125 because I took the $20 and then I'm saying $15 a day times 7 days and I'm adding them up. That's what we're thinking in our heads when we go in the store. So I'm going to show them how it would relate to the equation on the line. So I'd start with this problem, put it up, talk about it. Most of them would probably come up with 125. You know, once we kind of talked about what the flat fee was, they usually don't understand what that is because they've never had to pay it. But, you know, once I go in, you just walk in the door and you pay 20 bucks, then they get it. So we kind of start there, and they can usually get to the 125. But then I will start teaching them how it goes with graphing a line. If you will flip, I tried to put, oh, not this slide yet, sorry. So anytime I'm given an equation in math, I can put it into slope-intercept form if I'm talking about something like this. Most students are taught how to graph a line, but they do not know why it's important. Like when I started to take Algebra 1, my math teacher said, well, B is the y-intercept and M is the slope. Okay, so I was a really good student and I had all my B's and all my M's right. But you know what? I didn't really know what it meant. So when I present it with this same problem so that the student can put the connection of the word problem with the line, they start saying, oh, well, I see why you're making me graph this line. Boy, it's a lot easier this way. Well, I'm sorry, not all of them are this easy. That's always my answer. So if I look here, I'd say the slope-intercept of a line, most students are taught to graph a line but do not know why it's important. We will explain the importance by giving students examples like on the previous slide. So here, M is $15 a day. I always tell them anytime you're talking about per day or per hour or several days in a row, that's always going to be your changing number. So there's your slope. Then I always say that initial flat fee, whenever you walk in at time, I always start talking about time equals 0 right away, so that when they go into science later on, hopefully they will make that connection. But so I always say when you walk in the store, you haven't rented the car yet, you still have to pay the $20, even though it's at 0 for your time. So we have our equation where y equals mx plus b. Now I would have had a little more lesson on y equals mx plus b, so they didn't just start right here. All right, so flip the slide. And I'm going to try to graph this. And I realize I have really big numbers after I kind of sat here and looked at it a minute. So if I gave them, here it is, my $15 a day plus my $20 flat fee. If I wanted to graph this and I was teaching them how to graph in the process, I would say, well, here I'm going to start with time equals 0 right there. Because on my x-axis I would have 0. We would have practiced this before. Then I would say, well, here I'm going to start at 20 for my y. So I'm going to, since these are big numbers, I'm going to go ahead and put my 20 down here so that I can graph it. But I know here that my rate is going to be $15 per day. So as I start adding my days, I'm going to count these as days. As you can see, I'm teaching them the process of graphing, but I'm also talking about days, dollars, how it's increasing, so that hopefully all that will connect when I just start having them practice graphing lines and have them practice setting up the equations. So we have, here's our number of days is 1. Well, it's gone up by $15 after the first day, right? So I started at 20 at day equals 0. Well, here's my next, here's $15 because this would be 30. And here's going to be 40. So at day 1, I've already moved my point to now, instead of at 1 day, I'm paying $35. So after the second day, I'm going to add another 15. So there's my 40. I'm going to be up to 50. And there's day 2. So I have another dot. So instead of me just talking y equals mx plus b, here's my b, here's my m, I'm telling them what it means at the same time. And that's kind of what I mean by problem solving instead of just teaching the rote of m is slope and b is y-intercept. I still go over it, but I try to give them a very real life application at the same time. So what I'm also going to do is we're going to also talk about specifically word problems. So Ms. Ciccarelli is going to go through that. If there are any questions on that part? Okay.
Yeah, so we're trying to use real life application as much as we can in math. And as it gets, into more complicated math through the high school years, it gets a little more challenging, but that's kind of our goal here at Noble, is to be able to tie it into how it can be used in the real world. I have one student who every day asks how it's tied into the real world, and that's hard because I don't know every day. But we're trying to, make sure they see that it's not just memorizing and to understand it. So that we use for all grade levels. In lower division, the students were introduced to an algebraic thinking curriculum if they were here during that time that uses a problem-solving strategy called SOLVE. And then we continued using that in our algebraic thinking curriculum through the middle grades. And then sometimes we'll even revisit it in the upper grades in high school because it's kind of a way to organize their thinking when they're looking at a word problem that's overwhelming and they're not sure where to go with that. So for this word problem, I just picked one. I don't even know which algebraic thinking book it's from, but a typical, there's a couple steps going on. You can't just add all the numbers together and you get your answer. So it involves the students having to really understand the problem. So in this one, Jackie and Tracy were selling raffle tickets for the French Club fundraiser. Each ticket sold for $2. Tracy sold 43 tickets. The two girls sold 97 tickets between them. How much money did Jackie collect for the fundraiser? Soak in for a second. Okay. So if we have, you guys are at home, your student comes home and he or she is like, I don't know what to do from here. What do I do? I mean, it's very easy to say, oh, well, first you subtract 43 from 97, and then you have the amount of tickets, then you multiply by 2, and kind of like tell them more than guide them through the problem. So the idea of solve is to kind of give you guys some foundation so that you're not just telling them how to do the problem and that you're able to guide them more. So we make these in some of our classes. It's like a little flip chart. And if your student doesn't have this flip chart, there's also a sheet that we can share with you that you can have. We'll be getting emails, I'm sure, at the end, or you can give it to us if you'd like, and we can email you a copy of it. But it kind of helps you say with your student, okay, let's just first start by S, studying the problem. So looking at what the problem's asking you. Because in this case, the question is how much money Jackie collected. And I've done this problem with my kids, and always about half of the class tells me how many tickets she collected instead of how much money. So just helping your student by just having them focus in on what they're supposed to be finding and ask them just guiding questions to get them there is really just a good part to get started. And then from there, once they know what they're looking for, having them organize the facts by then reading through the problem and saying what's important here and bullet pointing those facts so they're not looking at a whole bunch of words, which can be really overwhelming. And outlining, is this fact important to what the question's asking? Is this one? So just using those guiding questions without telling them, this is what you need, this is how you do it. And then L, lining up a plan. So asking the student, well, now you have those facts, what can you do with them? How can we use those to reach what the problem's asking us, or S? And so these steps just kind of give you probing questions that you can ask your child without giving away the answer. And usually, they might not always get it right, but at least they're, slowly developing the critical thinking skills that they need for that. So they might realize, I need to figure out how many tickets Jackie sold. So 97 minus 43 that Tracy sold, that'll give me how many Jackie sold. Maybe you can guide them and say, well, okay, is that matching what the question's asking? And maybe that'll trigger them, no, it's asking how much money. So they'll realize they also need to use the fact that there's $2 per ticket. So just probing their thinking through these step-by-step process can kind of get them there with having them figure it out themselves. And then V is verify it with a plan, so they go through the process, and then E, examine the results. And that's key because a lot of my students are like, oh, I did steps, I'm done. But a lot of times if they look back and they say, wait, I just said that, she sold 54 tickets, but it only cost, $30. That doesn't make sense. That's not how much money she raised. I divided by 2 and I should have multiplied by 2. So having your child ask them, does that make sense? Like, is that how much money would make sense based on how many they sold? And just probing at the end to have them think about whether it makes sense and why, defending why it makes sense. So the great thing about this strategy is just it helps give you probing questions, outlining kind of what to do step by step with your student without kind of giving the answer. And you can use it for most word problems. I mean, I use it a lot for what we have in algebraic thinking, but it could be tied into any problems that they do in the future through high school.
And I think what we start doing more is we start abbreviating it. You were going through those same processes, but it'll be like, what's the question asking you? What does the variable represent? So we're doing the same thing, we're just not calling it solve.
Yeah, and I mean, they start off like writing everything out when they're in lower division, and then even sometimes in middle school, they're still writing them out if they need it. They slowly ease off of writing everything out and just like verbally saying it or thinking it themselves through. So they're slowly like getting weaned off the writing process and doing what you said, where they're doing it independently. Any questions? If you want it shared with you, I'm happy to, after, get your email, I can share it with you. And that's the strategy as well. And this will be on that's like the basic version of it. I have little extra support questions if you need, but that'll be on the website. So.
And one issue the kids run into in 8th grade, 7th, 8th grade is, if they are good at math, they've spent, up till 4th, 5th grade, they're coming naturally and not having to actually sit down and think about it and understand to actually learn it. So they can't just look at it anymore and say, well, it's 66.
And they'd still like to try to do that, but then I have to come back with, I get a lot of that too. It's a process, and as the problems become harder, the answer's just not going to be right there. So we need to think about what is being done in the process to go through the actual processing, which many of our students do struggle with processing. So that's one reason we just try to Let's stay with the process and go through the process. So, do y'all have any questions? We don't have many. We have a few parents. So, any questions for me, Ms. Chicker or Ms. Stitcher? Did we?
What kind of problem solving are you seeing that's, you know, hard for you guys at home? I saw Miss Bell. What are you guys kind of seeing? No one?
I
Sorry,
think that
Miss
it's
Bell, I
just,
meant
problem
Miss Smith.
solving is in everything we do. And that was my discussion today when the student who didn't understand what we were doing was unhappy and was saying, why do we need this anyway? And I was, because in everything we do, we problem solve. And it may not be the same situation, but it is learning how to break a problem up and coming up with a solution or working towards that solution. So, I hope that was clear, and we just need to start teaching it in conjunction more.
I think it's good. I wish I had been taught that.
It does, I think, makes it a little bit harder. You know, when we were just learning the road, it was so much easier, because we just had to memorize.
Yeah, but this gives it a reason.
Yes.
I mean, I remember all those formulas, but heck, I don't remember what it was for.
Yeah.
So I think this is really good for our kids that always want to know why,
Mhm.
you know.
Yes, definitely, and I do think it helps students who have processing problems, because it gives them a reason to go through the steps, where, you know, if they just memorize the steps and they have a processing problem of keeping up with their steps this way, well, let's see, I just found this, so now I need to find what this would be, you know, so it keeps them going when they can analyze what's going on in the problem.
And a lot of times, word problems are kind of like a story, you know, so what's happening in here, you're having and you can get their imaginations going too sometimes if, you know, we're having a fundraiser, and so you can imagine sort of the fundraiser and people selling tickets, and you've got these two girls, and, you know, so kind of give it a little action.
And it can pertain to
Especially with
them.
Maren, I know.
She you know, how's it gonna help me is how she is.
Right.
You know, and this could happen.
Mm-hmm.
Money's always
Right.
a good motivator when we get onto the money questions.
Right.
You know, I try to give as many money things as I can, because they usually care a little bit about money.
Yeah. You can't run a car until we're 25.
This is true. But this was for the parents.